Now, with this remark, we would like to take the idea of the time bandwidth product further. Now that we have identified two domains, let us put the domains together and bring out a new domain, a two variable domain. So, we shall henceforth talk of what is called a time frequency plane. Essentially a plane in which one axis, say the horizontal axis, represents time and the other axis, say the vertical axis, represents frequency. And therefore, what the uncertainty principle says is that if you wish to describe the occupancy of a function in this plane, you can think of each function in L to R we can think of the occupancy of x t in this time frequency plane. Occupancy is notional, and this occupancy can be thought as being from t 0, the center in time, to t 0 plus sigma t on one side and t 0 minus sigma t on the other. This is the horizontal axis, and on the vertical axis we could center it at capital omega 0, namely the frequency center, and we could spread it to omega 0 minus delta omega 0 or sigma omega, if you please, and above we could take it to omega 0 plus sigma omega. So, this is in some sense notionally the spread. So, you could think of that function x t as located in a rectangle which is centered at t 0 omega 0 here, which has a width or a horizontal spread of 2 times sigma t and a vertical spread of 2 times sigma omega. So, let me show the whole time frequency plane in some sense. What we are saying is, here you have the time frequency plane. So, let us mark it, this is the time frequency plane notionally. And a function x t occupies a rectangle in this time frequency plane, center t 0 omega 0, spread 2 sigma t horizontally, 2 sigma omega vertically. A very interesting concept. A function in L to R lies in a certain region of the time frequency plane. It occupies a certain area in the time frequency plane, and what the uncertainty principle says is that this rectangle cannot have an area smaller than a certain number. Uncertainty says the rectangle area cannot be smaller than, well, how much? 2 sigma t into 2 sigma omega, that is 4 sigma t sigma omega greater than or equal to 4 times square root of 0.25, which is 0.5. So, that is 4 into 0.5. That is the smallest area that it can have, 2 units. The area of the rectangle cannot be smaller than 2 units. Now, within that limitation, you can change the width and the height. That is also the positive side of the uncertainty principle. And in fact, if you wish to cover the time frequency plane with functions, what do you mean by covering a time frequency plane with functions? It means using functions which occupy different such rectangles in such a way that it gives you different information in the time and frequency domain about another function.